Again, it's another problem, and then let's start to solve it. So we have a car 400 kg and it is lifted up in this uphill with a motor with power, the power or torque M. For a short time the force in the cable is 3200 t squared. If the car has an initial velocity of 2 meters per second when the time is 0, determine its velocity when the time is 2 seconds. Okay, let's do that. Okay, first, always free body diagram. First step. Okay, the free body diagram means that free the body from the surroundings so that you can easily analyze it. So we have a force by the tension of the cable, that's T, and then we have a force, let me write it here. F, friction. And then we have a force that acts downwards. One more time. Okay, got it. And then we have a normal force also acting on the body. So normal force will be that way. Okay, and then if nothing about the friction coefficient, yes, if nothing is given about in the book about friction coefficient, then neglect the frictional force. Okay, that is the strategy in this book, because sometimes the book does not specify that neglect the frictional force. Okay, but in the book the strategy is that if it is not given, just you can neglect it. Okay, so the t value is given as 3200, so this one is 3200 t squared. Okay, that's the tension in the cable. Friction value, and then I will neglect it. Okay, and then we have the weight, and then we have the V1. Then the weight will be a little bit tough because I have to use this trigonometric relation. Let me just go in the next slide and then see how we can find the components of. Okay, let me do it here actually instead of moving in the next slide. So if I add, let me just. Okay, I will redraw this stuff here. So I have this inclined, and then I have here as the 8, I have as 17, and I have as 15, and I will call this one as theta. Okay, now let's add the weight. So I can say that the weight is, this is the weight, and then okay, let me add the coordinate. This will be x and this will be the y coordinate. Generally we take the x coordinate as the motion direction of the motion of the object, okay, because it makes things easier to solve. You can select x like this one. Okay, you can go, for example, y is like this one and then x like this one. Okay, this is up to you. Yes, this is not like compulsory, but the problem will be that if you select it, then none of your forces is oriented in x and the y direction, because you see the n is that way, f is that way, and none of them is oriented along the. So let me just add it in the next slide. So the selection of coordinate. So the first is that generally we select along the motion of object. So this is the one of the axis. Okay, so compare, you can compare, say that I have this one and that one, then y and then x. So the pros are, so the ff, then the t, and then the n are oriented along the axis, along either y or x. Okay. Or you can go something like this one, which is the another option. Then you can go x like that one, and then y is like that one. Then there is no pros. There are pros. You need to find it. The cons is that here none of the forces except the F gravity, or I will say it weight, okay, oriented along either y or x. That is the advantage of going with this way. Okay, so now let's find the components of the w. W will have a component this way along the x, I will call it wx, and then it will have a component this way, I will call it wy. Now the problem is, what is the theta here? Okay, that is the question that you need to find. Okay, for that one, let me do something like this way. I will go to one more slide here. So I have the body here, and then I have 15, I have 8, I have 70. Okay, and I say that show w here. Okay, it's like translate, and then this w will have again the components of then wx and then the components of wy. And then if I look for the angles, then I have the theta here, and this one is the 90 degrees. That's because the y into that axis, so that's the y. Let me just not to complicate the image, but you can see this is the y orientation. That's the, that's the x-axis, and they are perpendicular. So 90 degrees and then 90 degrees. And since it is 90, theta, and that will be 90 minus theta. This one and that one is also perpendicular, and therefore the angle here, so this angle will be also theta. Okay, so let's come back here. So then I will find out that this part is theta. Okay, now let's erase it actually, so because I showed in the another slide. So then time to write the forces. So I will have the forces in x direction, that will be max, and then forces in y direction, and then I will not put any acceleration, and that acceleration is 0 because in y direction I believe that it cannot move. So let's try and then solve it. Okay, let me add one more presentation here slide. So actually I will add two more. Okay, and then okay, anyway, so the forces in x direction, then we have the tension, and then that tension is positive, so tension plus, minus actually, wx, and that will be equal to max. Okay, then if I selected the wrong direction, then it will correct it. So wrong, if wrong direction is selected, So problem solution will correct it. Okay, so then we have the t and then we have the wx, and then t value is 3200 t squared, and then wx is then w sine theta, and then the m is 400, and then w value is 400 times 9.81, and then sine theta is, if you look at here, then sine theta is, this is theta, okay, 8 by 17, and then cosine theta is 15 by 17. Okay, so we have the 8 by 17. So let me pause it, and then next recording I will continue.